question, we will be studying the momentum principle, the isolated system, and the conservation of momentum. Let's take a look at this question. Three carts A, B, and C of mass 1 kg each are initially at rest on a frictionless horizontal track and located 2 meters apart from each other. Each cart starts to move along the track with speeds 3 meters per second, 1 meter per second, and 0.5 meter per second, respectively, as shown in figure 5. The sides of each cart are lined with Velcro that makes them stick together upon any head-on collision. Cart A and B collide together first, before colliding together with cart C. Calculate the magnitude of the resultant train when cart A collides with cart B. Now, how shall we tackle this problem? We're going to use the conservation of linear momentum. So let me write it down. We're going to apply the conservation of linear momentum. Now, what does this principle states? It means that the total momentum before collision is equal to the total momentum after collision. So let's proceed to calculate the total momentum before collision. Well, let's calculate the momentum of cart A. So the initial momentum of cart A is ma times its initial velocity ua plus the initial momentum of cart B, which is mb, times the initial velocity of cart B. Now, after collision, cart A and cart B sticks together because of the Velcro. So now it is a combined system, meaning the two carts are now combined together. Therefore, the combined mass of this combined body, which we call the system, is ma plus mb. And the final velocity of this resultant train after cart A and cart B collides together, we are going to denote it as VAB, which is also the resultant velocity we need to find. Let's put in all the values that we know. So cart A is 1 kg, and its initial velocity is 3, plus cart B also 1 kg, with its initial velocity to be 1 meter per second, and the total mass is 1 plus 1 multiplied to the velocity of the resultant train. So upon solving this equation, we'll find that the velocity of the resultant train is equal to 2 meters per second. And we notice that it is a positive value of 2 meters per second. Why? Because we take this direction to the right, to the positive direction. Hence, the velocity of the resultant train is to the right. For the second and final part of this question, we're going to look at the magnitude of the final velocity of the train of the three carts. Now remember, in the previous part, cart A and cart B has collided together and have stick together and move off as a body. And together, this combined mass of cart A and B will collide with cart C. We're going to apply the conservation of linear momentum again. So I want to write here, apply the conservation of linear momentum again. So this time, what is the total initial momentum? Well, it includes the combined mass of A and B moving with a velocity AB as calculated in the previous part, plus the initial momentum of cut C, which is MC, multiply the initial velocity of cut C. Together, these two add together will give you the total momentum before collision. Now after collision, cut A, B, C stick together and move off with a common velocity. So the combined mass of this train will be MA plus MB plus MC. And this common velocity, I'm going to call it VABC. And this will give us the total momentum of the resultant train after collision. Now, let's substitute the values that we know. The combined mass of AB, right, will be MA plus MB. And the velocity of this resultant train of cut A and B, as found in the previous part, is 2.00. Now, the mass of cut C is 1 kg, and its inertial velocity is 0.5 meter per second to the left. So we must add in a negative sign to the velocity because it's moving along the negative direction. Why? Because remember, we have stated that we have chosen direction to the right to be positive. Then the combined mass of cut A, B, and C is 1 kg plus 1 kg plus 1 kg. Multiply to the common velocity of this resultant train of cut A, B, and C. Now, this combined mass of cut A and B, we know that it is 1 kg plus 1 kg. And this is 2. And rewriting the whole equation again. So this will add up to be 3 and VABC. Now, solving this equation, we'll see that VABC is equal to 1.20 meter per second. And since this is a positive answer, it means that the final velocity of the train of 3 cars is actually to the right. And with that, we have solved this problem. I hope this example will give you a better understanding of how we use the conservation of linear momentum to solve problems. Thank you.